Hi guys, welcome to TP Coder channels. For this video, I'm going to show you how do I work on the AI modeling part for the water quality datasets. Let's get started.
Hi guys, thanks for watching my video. Let's get started. First of all, let's do the same thing. Like we open up our Anaconda prompt, and then we will navigate to this particular directory that we have been created. And here, so we're gonna conduct activate water quality, and then we will start our Jupyter notebook here. And here, we're not going to use back the data preprocessing's Python notebook, but instead we're going to create a new one. So I'm just going to create another Python 3 notebook here, and then I'm just going to rename it for model training. First of all, we're going to do the same thing, that we're going to import pandas SPD because we're going to read in our dataset again for the model training purpose, and then we're going to import numpy s and p. We're gonna use numpy for later on as well. Then we just run this. So once we have successfully import our pandas as numpy and numpy library, so we're gonna read in our data frame. So I'm just gonna read in both data set. One is the uncategorized and one is the categorized one. So for the categorized one, I'm just gonna name it as df1. So I'm just gonna say pd.csv, and then I'm gonna put in the name, and then for df2 we're gonna read in the uncategorized one. Okay, just to make sure we have been successfully read in the data frame, so let's print out the info. Let's run these cells. We will go for the next steps. We have not much of preprocessing need to be done here. The only thing is we can just gonna split out the features and also the target for each data frame. So I'm just gonna say that df1.features is equal to df.log all the rows, and then df.columns that are not equal to portability, and then sorry, this one is df1, and then for df1 labor will be say df1 dot portability. Okay, see for df2, so we're just gonna name it as df2.feature underscore feature is equal to df2.log all the rows, df2.columns which are not equal to portability, and df2 underscore label will be df2.portability. So we're gonna work on these two and train each of them with the same model. So today I think we're gonna just try on 3 different algorithms. So the fundamental one we will go for the decision tree, and then the next one we will try for the random forest, and then the last one we will try for the gradient boosting algorithms. Before that, let's run these cells. Okay, first of all, we're gonna import from sklearn model selections, import train test split. We're just gonna name it df1 train x, df1 daily. We're just gonna say test x, then df1 train underscore y, df1 underscore test y is equal to train test split. Then we're gonna put df1 features df1 labels test split will be equal to 0.2. We're just gonna split up 20% of the data frame as a test set, and the remaining 80% of the data point will be used for training. Then the random stage means that all this splitting will be in random. So, but of course, we can specify the random number so that in the future we'll manage to actually get back the same train and test split set with this particular random stage number. This will be test size and state. So we're gonna do the same for df2 as well. df2.train x, df2 test x, df2 train y, df2 test y. And then we're gonna say train test split df2 underscore features df2 underscore labels right test size will be 0.2 random state as well. So until here, I think let's run this cell and we are ready. Okay, first of all, we're gonna train for decision tree models first. So we're gonna import from sklearn sklearn.tree import decision tree classifier. Then we're gonna instance our decision tree models here. DCT, which stands for decision tree 1, right? Then I'm gonna say decision tree classifier. So we're just gonna leave all the parameter as default, and then I'm gonna do dct underscore dot fit df1 underscore train x df1 underscore train y. And then I'm just gonna do the same for the second data set. So decision tree classifier, there shouldn't be a space here, and I'm just gonna say dct underscore true dot fit df2 underscore train x df2 underscore train underscore y. So I think I'll just make a comment here to specify that df1, which actually is our categorizes, and df2 will be uncategorized. Before that, I'm gonna from sklearn import matrix. So I'm gonna say dct underscore dct1 underscore result will be dct underscore 1, which is our model, dot predict our test set. So it should be df1 underscore test underscore x. And then we're gonna do dct2 result as well. Let's go to dct underscore 2 dot predict df2 underscore test underscore x. For next, we're gonna print out the confusion matrix for the model 1. It will be matrix dot confusion matrix. So df1 underscore test underscore y and dct1 underscore results. Then I'm going to do for the second one as well. Matrix dot confusion matrix tf2 underscore test underscore y dct2 underscore results. And then I'm gonna do for the get the accuracy as well. For accuracy 1 will be matrix dot accuracy underscore score df1 test by dct1 underscore results. Yep, then I'm gonna do for accuracy underscore 2 as well. I'm just gonna copy and paste because it's the same thing. And then I'm gonna get the precision 1. Then will be matrix dot accuracy score. Then the last one will be the recall. Then we just gonna print out everything. And what I'm gonna do will be the confusion matrix. Okay, let's run this out and see how's our model training for the decision tree. For the uncategorized one, you can see the accuracy only get around 61%. For the uncategorized one, it looks just a little bit better when we are using the so-called decision tree classifier. So it's around 1 to 2% differences, but it seems that uncategorized will be better for this case. For the next one, I think we'll be using for the random forest classifier instead. For the random forest, we can from scalar.ensemble because random forest is an ensembling technique that ensemble up multiple decision trees. So scalar.ensemble import random forest classifier. So I'm still gonna do the same thing. RFC underscore 1 stand for random forest classifier number 1. It will be just an instance of random. For this, I'm just gonna say RFC 1.fit. It will be df1 underscore 3x and df1 underscore 3 underscore y. Yep. Then we will be focusing on random forest classifier 2. Dot fit df2 underscore 3 underscore x df2 underscore 3 underscore y. We're gonna do the same thing as the decision tree classifier. So after we have been successfully trained, then we just gonna do the prediction. So I'm just gonna copy and paste instead because I'm lazy. So I'm just gonna rename this as RFC1 result instead, RFC2 result, then gonna use RFC1 to predict. Same for the RFC2. And yep, we're just gonna use this data test set, DF1 and DF2. So what's next will be CFN underscore 1, but this time I'm just gonna say with RFC, it will be matrix confusion matrix, right? So we're just gonna put in the DF1 test score 1 and our RFC1 results. Yep, correct. So same for the, I'm just gonna copy and paste this instead. And it will be CFM2, TF2, RFC2. Then we're gonna do for the accuracy 1 RFC matrix dot accuracy score, and then it will be same parameters. Okay, let's run for the random forest classifier. There are some errors. Okay, that should not be a capital L. Just a small, yeah, some typo here. Let's rerun this. Okay, so yep, we can see that if we are using random forest instead, it will be better result for both data set. Which one for the, this one will be for the categorize, and this one will be for the uncategorized. We get around 71%, I would say, because we round up, we will get around 71% of accuracy for the uncategorized one, and for we get around 64% of accuracy for the categorized one. So until here, we can observe one thing, like it predict better or train better with the uncategorized one instead of the categorized one for both decision tree and also the random forest classifier. Let's go for the last one, and we just want to try and see whether the so-called gradient boosting algorithm, whether we train better on both of the data set, so that we can decide which model gonna be used for the serving part for our last videos. So yeah, let's start with the gradient boosting algorithm. So still the same, we're gonna from ensemble. So sorry, it's ensemble. Then import gradient boosting classifier. It's not boosting, it's boosting. Everything will be the same. GBC1, I will say is that gradient boosting classifier. Why on type Boston? So yep, GBC2 is the same thing. Boost. So we will leave the parameter as default. Once we have been done training, so we're just gonna run for the prediction. I'm just gonna see is the GBC2 underscore results Right, so I'm going to say gbc1 dot predict df1 underscore test x. Oh, so gbc1 gbc2 score results gbc2 dot predict df2 underscore test x. Yep, everything looks good until now. And then we're gonna get the confusion matrix. Yep, it looks good now. I think we can just go ahead and click run. Gradient classify is okay. It should be gradient boosting classifier. Alright, the gradient boosting classifier, we get an accuracy for the uncategorized one. This one will be categorized, and this will be uncategorized. Let's have space in between here. Save it. And for the categorized one, we get around 63% of accuracy and get around 65% of accuracy for the uncategorized one. It seems like for this dataset, currently the best accuracy that we can get out from these three modeling is with the random forest classifier, and is trained by uncategorized dataset. So yep, I think that's it for all the model we're gonna train. And then for the last step, what I'm gonna do, it will be saving the best model, which is this one, by using Pico, right? So for ready for the model serving part. So the last part, what I'm gonna do will be import Picos. Then I'm just gonna given a name for the models. So I'm just gonna say this is the water quality best model dot pkl. Then I'm gonna do pico.dump in our model name, which is the random forest classifier 2. And then we're gonna open it as a file, right? We put in the model name and then right back. Okay, so let's save this. If we go to look for our working directory, and we're able to see there is a model successfully saved as water quality best model.pkl. So this is our model that we're going to use for our model serving later. So just to have a quick checking whether we're able to load the model and do prediction again. So what I'm going to do next will be this load model pico.load with open model name and then back. Then test results go to load model score. Let's use back our df2 test x, df2 test y, and then let's print out the test result. Oops, result score not underscore. We get a 70%, which is matched with our training testing just now. Until this point, we have been successfully trained our models with the two data sets we have been prepared from the data preprocessing videos. And then we have been trying with decision tree, random forest classifier, and so random boosting classifier. And then our conclusions that we get from these three modeling technique, we're able to get around 71 or 70.8% of accuracy by using the random forest classifier, which is trained on the uncategorized data set. We have been successfully saved the best model, which is the random forest best models, into a PKL file. And then we been trying to load the model and run the prediction again, and it proves it works. Until this point, we are ready for our model serving part. Thank you very much for watching my video, and see you in the next video. Bye bye.